In the previous video, I talked about the Huygen's principle. Okay, and there are two principles. Now we are going to use the Huygen's principle to prove the law of reflection. So let us discuss and try to prove the law of reflection of light on the basis of Huygen's principle. Now in this ray diagram as shown here in the board, you can see that this AB here is the incident wavefront. Alright, it is an incident wavefront which is making an angle I with the mirror M1, M2. So obviously here the angle I is the angle of incidence. 1 and 2 are the corresponding rays that are perpendicular to the incident wavefront. We know that the rays of light are always perpendicular to the wavefront that they represent. Okay. Now, this ray of light, when it comes here, the first ray of light, number 1, when it comes here, it is incident at point A and it gets reflected. Okay. So similarly, the second ray, it comes here and it incident at A dash and gets reflected. Got it? Now, the Huygen's principle. The first Huygen's principle says that every point on AB is a source of secondary wavelets. All right. So let's say we consider a secondary wavelet from point B. Okay. A secondary wavelet from point B. This secondary wavelet will travel and it will reach A dash. It will strike the mirror at A dash. Let's say after T seconds or after time T. Understand? So we can just imagine this surface to be water. Can we do that? Let's imagine this to be water, and we are looking at the surface of water from the top. This is the top view. All right. So what we are going to do is we are going to drop two pebbles at point B and at point A. All right. So we drop at the same time, exactly at the same time, at point B and at point A, we drop pebbles of the same size, let's say marbles of the same size. So do you agree or not that when you drop a marble at point B, there will be the ripples that form? There will be ripples that form like this. Okay, the ripples will grow, right? The ripples will grow like this. Obviously the ripples are round, but I'm not going to draw the round thing out here. So with time, this ripple, it will grow, and after some time it will strike this point A dash. Okay, let's say after time T, the ripples from point B, they grow and travel and strike the mirror at A dash after point T. Is this after time T? Is that clear here? So similarly, the ripples from point A. Okay, the ripples from point A, let me draw that with yellow. At the same time, the ripples from point A will grow like this. Okay, it will travel, and in the same time T, it will reach this point. Is this clear? So let me explain that once again. We are assuming that this is the top face of water. Let's say this is a water tank. All right, and we are able to draw these rays on the surface of water. Okay. Now we drop two marbles at point A and at point B exactly at the same time. So you understand that whenever you drop a marble or any stone or any body in water, the ripples will be formed. Yes or no? So the ripples from point B will travel like that. Okay, it will travel. Obviously, I told you that the ripples are actually round. Okay, they are round like that. All right, they are round like that, but I'm not going to draw the round thing like this. I'm going to concentrate only on this side. So the ripples will grow, right? With time, it grows like this, and after time T, it strikes point A dash. Okay. Similarly, the ripples from point A will grow like this, and it will travel at the same time. After the same time T, it will reach this point. Okay, now what we are going to do is we are going to draw a tangent plane from A to this secondary wavelets from here. Now what does this second principle of Huygens says? The second principle says that if you draw a tangent plane a plane which is tangential to these secondary wavelets at that instant of time. That means at the same time. That tangent plane will give the secondary wavefront. So this tangent plane A dash B dash, this will give the secondary wavefront. Is this clear here? And it is clear from the figure that this secondary wavefront makes an angle R with the mirror, which is the angle of reflection. Okay, so consider a plane wavefront AB to incident on a mirror M1, M2 at an angle I, the angle of incidence. 1 and 2 are the corresponding rays which are perpendicular to AB. We know that always the rays of light are perpendicular to the wavefront. According to Huygen's principle, every point on AB acts as a source of secondary wavelets. Let the secondary wavelets from B reach the mirror at A dash after time t. So therefore BA dash is equal to CT. We know that distance is speed into time, where c is the speed of light in the medium. Okay, so that is what I explained to you. The secondary wavelets from this point B, they travel, okay, and they reach the mirror at A dash after time t. So therefore this distance BA dash, this is equal to CT. With A as a center and radius equal to CT, an arc is drawn. The tangent A dash B dash to this arc serves as the secondary wavefront in the time t, according to what? According to the Huygen's second principle. Okay, so this means that we are taking A as a center and we measure a length equal to CT and we draw this arc. Okay, so this means that AB dash, that is the radius of the arc, and what is the length of this AB dash? That is also equal to CT. Alright, so therefore AB dash is equal to CT. Now what we want to do, what we can do is we will just take the two triangles. Which two triangles? These two, AB dash and AB dash A dash. Alright, so we will just show that these two triangles are congruent to one another. What is the meaning of congruent? Congruent triangles means that the two triangles are equal in all respect. That is the meaning, okay? Equal in all respect means that if you cut this part, if you cut the angle, the triangle AB A dash, and you paste it in AB dash A dash, it would be exactly the same shape and the same size. That is the meaning of congruency of two triangles. All right. Okay, so what we do here is we take these two triangles, ABA dash and AB dash A dash, and we look at these angles out here. ABA dash, that is equal to AB dash A dash. Which angle? This one, ABA dash. That means this angle is equal to AB dash A dash, that angle. Why? Because they are both 90 degree. They are perpendicular. Each of them are 90 degree. Okay. BA dash is equal to AB dash from equation 1 and equation 2. So let us look at equation 1 once again. See, equation 1 says that BA dash is equal to CT. And equation 2 also says that AB dash is equal to CT. So therefore, BA dash is equal to AB dash. And also in that triangle, A dash is equal to A dash A. Why? Because these are nothing but common side. Okay, the side A dash is common to both the triangle A dash and the triangle AB dash A dash. Understand? So we have a congruency criterion called the SAS, congruency criterion. I don't know whether you remember the SAS congruency criterion in your lower classes geometry or not, but there is a congruent, all right, a congruency criterion. What is it? SAS. Okay, S means side, angle, side. So here you have one pair of side, one pair of angle, and one pair of side. So this means that the two triangles are congruent to one another. And what did I tell you? That if the two triangles are congruent to one another, then they are equal in size, equal in shape. So it means that these angle, the corresponding angles I is equal to another angle R out here. Okay, but what is I is equal to R? Isn't this the law of reflection, right? So moreover, if you look at the ray diagram, you see that the rays the ray number 1, ray number 2, the ray 1 dash and the ray 2 dash, they lie on the plane of the board. Even the normals, the dotted normals, they lie on the plane of the board. So therefore, the incident rays 1 and 2, this is not refracted, this should be reflected. Reflected. I made a mistake out there. The reflected rays 1 dash and 2 dash and the normals all lie on the same plane. Thus, the law of reflection is proven. Okay, so this is how you prove the law of reflection based on the Huygens principle.